Today we're here with Dr. Berghorn from Michigan State University, and he is going to talk to us a little more about research in construction. So thank you, Dr. Berghorn, for being here. The first question I have is essentially if you can tell a little bit more about yourself in general and about your teaching and your research at Michigan State.
Sure, I'd be happy to, and thanks for having me as part of this series. It's great fun to be able to reach out to more students than who I would normally get to talk to. So by way of background, I grew up in a family that was involved in the construction business. My grandfather and uncle were both carpenters, and so I got some interest in it that way. I worked for an HVAC contractor when I was in college, and I did some other sort of more like laborer work along the way. I got out of school, I went to work for an engineering firm, and then that transitioned into going to work for one of our subcontractors. I was a superintendent, a site superintendent, and then a project manager for that firm out on the East Coast. I was based in New Jersey. And yeah, then I decided to come back to school, came to Michigan State, got a PhD in construction management at MSU in 2014, and then joined the faculty a year later. In terms of my teaching, I teach one of our capstones for seniors. I teach the residential construction capstone, which we base that around the NAHB competition problem every year. So we have a large group of students that work on those projects for class, as well as I coach the competition team. So we take one group of students out from that to compete. I teach an introductory sophomore level green building class, and then I teach a senior/graduate level advanced energy efficient and green construction course as well. And then my research really started in sustainability. I've done a lot with energy efficiency and sustainability, and in the last 5 or 6 years, it's almost completely transitioned to mass timber related research. And so I'm now the research director for an entity that we have at MSU called Mass Timber at MSU. So I do that work. I still do a little bit of work on sustainability and circularity of materials, but primarily now in mass timber.
So can I ask if you can explain a little bit what mass timber is, since some of our listeners might not know?
Absolutely. So mass timber is sort of a shortened way of saying massive timber. And it's really a more modern take on what we see in some older construction styles like post and beam frame construction, where large cross-section solid sawn wood members were used as the primary structural elements. In mass timber construction, those elements are now made of laminations of wood and resin to make, again, these very large cross-sectional area materials that can be used for the building's gravity frame. It can be used to support lateral loads in buildings. And then we can also use those materials as decking as well. So cross-laminated timber, which is a layup of dimensional lumber where every layer is laid at 90 degrees to adjacent layers, can be used as decking material as well as self-supporting walls.
Okay, very interesting. So now we're going to shift gears a little bit, and I'm going to ask you, how do you define research in construction?
Yeah, it's a great question. And, I think research in general is really just this idea that we're on the quest for new knowledge. And we do research all the time, and we don't maybe think about it in a very academic way. But if we go to buy a new car, we do research. When we're buying a house or renting a new apartment, we do research. And all we're really doing is seeking information. And I think in the academic context, the difference is we're always seeking new information. We're always trying to push the envelope and learn something new. And where I think it intersects with construction is we're not just trying to learn something new. We're not trying to discover a new isotope of some chemical element. We're trying to discover something new to solve a problem. Our field, I think, is very applied. Most of the research that I see people doing within the construction space has much more of an applied touch to it than what you might see in a chemistry department or a mathematics department, because really we're after knowledge that will solve problems. And so I think the majority of the research that I do, I think we try to do that. We try to answer critical questions that will solve some pressing need or solve some pressing problem.
Perfect. That is very aligned, at least with what I think. So now, talking about your opinion, how partnerships between university and industry can move construction industry forward?
Yeah, I think those partnerships are critical. If you go back to my opinion, my definition of research and construction, if we believe that research and construction is geared around problem solving, well, where do those problems come from? Those problems should be coming to us from industry, from people that are faced with these challenges every day. And I think where we sometimes then have the flexibility to move in to that space is, and again, coming from industry, I thought about how much money I was spending. Sometimes it felt like every 15 minutes I was worrying about how much money I was spending, but certainly hourly, daily, weekly. And you just don't have the time to go out and answer the questions that you might want to answer. So partnerships between industry and academia are critical, because I think we on the academic side can take some of those challenges that industry members are facing, and we can really explore that in greater detail. We can take the time to really try to break down those problems, understand them, understand the complexity, and then propose solutions, and then work with our industry partners who then have a test bed where those potential solutions can be test driven, can be prototyped, test driven, whatever the phrase you want to use is. But again, I think in the absence of those partnerships, we're sort of off in a direction doing work that may or may not have that direct benefit back to industry. Conversely, and this is one of the challenges with some of the work that I do in mass timber, because it's so new, it's difficult to find industry members that want to share a lot of their data, especially around cost performance. So having partnerships is critical, because partnerships mean you have a relationship of trust that's been built, a good working relationship with one another, and we can overcome some of those barriers to get some of that data that we can then slice and dice and analyze in different ways to, again, help answer some critical questions.
Feels like you described a lot of the industry, even if you were working in the field, right? So the need of trust, the need of developing partnerships.
Absolutely.
Very good. So now, what do you see as hot topics of research that advances, and which advances do you see happening in the field in the next, 5 to 10 years?
Yeah, I think there's a lot of change. I really think we're standing sort of on the edge of the cliff, where we're going to see change start to happen more rapidly. So in no particular order, I think we're going to see more virtual design and construction technology applied, even in residential construction, even in things like single family detached residential construction, where there's going to be more emphasis placed on being able to see things in a virtual space before signing a contract or making a decision to then create your space physically in that way. I think project management tools are going to continue to shift and utilize more technology within the residential sector as well. Added to that, I think we're going to see more, maybe a little bit of a return to where we were 20 years ago and then a growth from there. But I think we're going to see a return to more interest in prefabrication and modular housing, especially with more emphasis and more concern about what's happening with the environment and ways that we can minimize waste, ways that we can be more efficient from an energy perspective and a carbon utilization perspective. I think prefabrication and modular will have a lot of promise for how customers will start to respond to some of that environmental concern and environmental interest. And then companies, of course, will come along to satisfy those customer needs. I think we're going to see more connected and smart cities. And so we're going to have to design and build buildings that operate within this idea of connected and smart cities. So yeah,
So again, for our listeners, some of them might not be familiar with the term. So if you would mind kind of explaining what you mean.
Yeah, so smart cities are basically this idea where every function or every service within the city is fully integrated with Internet of Things, IoT capability. So everything, now we think of what can we do with an Alexa or,
Mm.
a Google Dot or something like that. Now imagine if your entire city, your entire infrastructure was smart and connected and had two-way communication ability with other aspects that use that infrastructure. So homes that can communicate with infrastructure. So we have smart utilization of electric resources at times of day when demand for electricity is lower. And when demand goes up and there's the sense of an impending brownout or blackout, homes can sort of regulate themselves in terms of switching less critical loads off, keeping critical loads for critical functions of the home running. This seems to be the way that urban planners are thinking about cities. And so, of course, we're going to have to build structures that can operate, inside of that framework. Let's see, a couple more. I think we're going to see more living building materials, so bio-based building materials that are self-healing and self-repairing. As we've learned in the last couple of years, things change drastically. It's not so easy to just go out and buy a new material these days. And so if we can start to move to a future where materials can repair themselves and heal themselves, I think we're going to see some very different performance in our buildings. I think we're going to see more drone utilization. I mean, within the residential sector now, if we're talking single family homes, a lot of drone utilization is more from like a real estate perspective and a land development perspective. But I think we're going to see more use of drones to be information gathering tools as neighborhoods are being built, as subdivisions are being built. And then finally, I think we're going to see more technology spill over into the safety aspect of construction. We've started to see it on the large commercial and industrial side, but I think we're going to see it spill to the residential side because frankly, for all of our innovations in safety that we've made over the last 10, 15, 20 years, construction still remains one of the most hazardous occupations in the United States. And particularly for a small residential operation, losing a person due to an accident, losing a worker due to an accident can be a crippling experience for that builder. So I think we're going to see more tech-assisted safety advance in our field as well.
Very good, very encompassing. A lot of ideas for our listeners. So now let's talk about your current research. Can you describe, I know you all already talked a little bit about it, but if there's anything else you want to say about your line of research and how and why you chose it?
Yeah. So I think the reason I sort of fell into doing this mass timber work, I got a phone call about 6 years ago from a colleague in Michigan who was applying for a grant. And he said, yeah, it's something about mass timber. And I figured you might know what that is because you have a forestry degree and you have a construction degree. And I think you should know what this is. And I said, yeah, kind of. I've been reading about it. Some students had an interest and they did a project about it. And so I've been learning a little bit. Sure, let's do it. And fast forward 6 years later, and we've built up a pretty good focus area here at MSU around mass timber. We've done a lot of sort of regionally and nationally recognized work in the last few years. So I get excited about it because what mass timber represents is really a paradigm shift within construction. It represents how offsite fabrication and modular components can be brought into the mainstream to deliver a much wider variety of buildings than what we've seen delivered using those modalities. Mass timber exists in schools, office buildings, mixed use, healthcare facilities. The tallest mass timber building in the world is currently in Milwaukee, Wisconsin, 285 feet or so. So, there's a lot that's possible with this material, and it's exciting to me because it addresses some key problems that we face in construction. First, it addresses the problem of labor shortage. Because the products come out prefabricated to the job site, you can put these structures up with smaller crews. Wood, it's also pretty well known that wood has a higher strength to weight ratio than steel. Sometimes that gets misreported as wood is stronger than steel. Wood has a higher strength to weight ratio than steel, right? So for the same structural performance, you get a lighter structural element, you get a lighter structural member. So again, you can decrease the size of the crew that has to be used to assemble a building using those materials. The other issue it addresses, though, is frankly this emphasis that we've had in the last decade or so on sustainability. Wood, as we know, the way wood grows, trees grow by taking carbon dioxide out of the atmosphere and then packing that carbon onto their physical bodies and growing biomass. So wood is a big storage body for what was once atmospheric carbon. Well, if you don't have any use for those trees, if you can't think of a use for a certain species or a certain size, by and large, those trees tend to die. When they die, they either decompose and release carbon back to the atmosphere, or they might be subject to a wildfire where, again, they burn up and they release carbon back to the atmosphere. By being able to harvest a wider variety of species, smaller size trees to make these products, we're now locking up a tremendous amount of carbon inside of those wood products. And so we have a mass timber building here at MSU. 3,000 cubic meters of wood is in the mass timber part of the structure. Those 3,000 cubic meters store about 1,856 metric tons of CO2 equivalent. So what's that mean? That's like not driving a car for 4.7 million miles, just with the carbon that's inside one, right? Just one structure. So that structure by itself isn't solving anyone's problem. But if you start to build an entire community, an entire city like this, now you can start to store more carbon in these long-lived wood products. And frankly, the manufacturing of mass timber is less carbon intensive than the manufacturing of some other conventional building materials. So it's got a smaller carbon footprint. It stores carbon through the life of the building. So those were the two main attractants for me, the sustainability benefit and this kind of addressing the construction labor shortage aspect. So the work that I do looks at construction management aspects. I look at things like cost and time of putting these structures up. We've done some work on predictive cost analytics, predictive time analytics from the construction side. We're currently doing some work on education. So we're building a national model curriculum for post-secondary AEC programs at MSU that's funded by the National Science Foundation. That just kicked off this summer. We're doing some work on understanding demand for these buildings. So from a developer and AEC community perspective, but also from an occupant perspective. We want to know, like, the people that are renting apartments in mass timber buildings, the people that are renting business space in mass timber buildings, why? What's attracting them? Why are they coming to these buildings? Are they willing to pay more? Are there performance attributes that are important to them? So trying to understand that. And then we're doing some sustainability work that's focused on end of life. So we're trying to figure out in 60 years, what happens to these materials in buildings when those buildings inevitably reach the end of their useful life. Right now, there's concern because it's wood and resin pressed together. There's a question of, well, what can you do? It's basically the wood is basically contaminated with a glue, with a resin. So we're looking at ways that we can get some better end of life performance out of these components, out of the buildings that we build, so that we're thinking ahead to the end of life, which seems a little silly when it's such a new idea, such a new material, but I think it's important. We shouldn't go blindly into something without thinking about the end state for that material.
Very interesting. I'm going to deviate just a little bit because I found this topic really interesting. And I want to know, what are your views of what's happening to mass timber use here in the US right now? Where is this like getting warmer, the market? Just talk a little bit more.
Yeah, the market's really starting to get a lot warmer, hot in the US. So mass timber got really popular in the Pacific Northwest. They were kind of the early adopters of this material going back now, probably about 10 years. Oregon specifically led a lot of that early work. California has a lot of buildings that I think California has the most mass timber buildings of any state in the country right now. But there's been a sort of a second wave, and that second wave has happened within the Midwest and the southern United States. Walmart is currently building a 1 million plus square foot campus in Arkansas, and they're doing everything in mass timber, to the point that Walmart actually brought a manufacturer from Canada to site a manufacturing plant in that area down Arkansas, Texas, in that area to manufacture enough wood for them to use in their project. And now we're seeing great interest here in the Midwest. Just in Michigan, we have the first mass timber building in the state here at MSU. But I should say, let me rephrase that. The first significant mass timber building. Northern Michigan University's football stadium is covered by a dome, and their dome is a glue laminated timber dome that was built in the late 80s. But our building is the first sort of building, right? Not a sports facility, not a dome, a building. So we went first. We're now tracking somewhere between 25 and 30 projects in the state that are interested in using mass timber. They're either in somewhere from conceptual design all the way up to pre-construction that are looking to use mass timber. A local manufacturer down south of Chicago that had been manufacturing crane mats out of cross-laminated timber just recently got certified to make building panels. They can produce panels at a very, very fast pace. Their production is incredible. So I think they're going to be a game changer. We have a new manufacturing facility about 200 miles away from East Lansing in Canada that's manufacturing mass timber. So it feels like the right time. It feels like this is the time where there's the buildup of enthusiasm, and it's really about to explode.
Very good, thank you. So now just getting back to what we came here to talk about. But I guess it's going to be related. So can you describe one recent project that you are working on and have recently worked on?
Yeah. So I'm going to talk about the education project. So this is National Science Foundation funded to develop this national model curriculum. What's exciting about it for us is that we're focusing on both 2-year programs and 4-year and graduate programs. So we're really trying to hit the continuum of students across all different levels of education. The curriculum that we're developing is modular, so that way it will fit into existing programs very easily. We know that most architecture, engineering, and construction programs are accredited, and accreditation leaves often very little room for electives and things like that. So we're just creating modules. So, you can plug in the modules on scheduling into your scheduling class. You can plug in the estimating modules into your course that covers estimating if you want. So that's kind of an exciting piece. And then the other exciting piece is that we're using a significant amount of virtual reality and augmented reality environments to deliver the training. Because one of the issues with these buildings is that once they go up, you can't really see the connectors anymore. You can't see how the building was assembled. And we also recognize that a lot of students that may be interested in this don't have the ability to go see a mass timber building in their community. Yeah. So we're in the process of virtualizing our building at MSU. We're adding a bunch of interactive features to it. And then we'll have some augmented reality pieces where students can literally take a section of the building, sort of break it apart, spin it around, look at the connectors, how the connectors work, pull up cut sheets for the connectors, product literature about the connectors, things like that. So we're pretty excited about it. We think it's going to be a pretty good project by the time it's all said and done. It's a 3-year project. We just started this summer, so we're just getting started, but it's going to be good, some good work coming out of that.
Great. And how about you explain a little bit what was the motivation behind the project? I can understand a little bit more, but if you can speak to it, that would be great.
Yeah, so we did a couple of years ago, we did a barriers survey that focused primarily among industry members. What are the barriers to adopting mass timber? And a lot of the barriers that came up were I would call them information-based barriers, lack of information, right? We don't have information about cost. We don't have information about how this fits into existing building codes. We don't have information about how we should run the project from a project delivery process way. Like, how do we do this? How do we incorporate mass timber? And we thought about it and we said, you can go back to the industry and you can create all kinds of continuing ed and outreach training to industry. And that's going to have some level of impact, of course. But then the more we thought about it, we said, if we reach out primarily to students are the future leaders of this industry. And given the labor shortfall that we're facing, their movement into management is happening faster and faster. I think about my own students that have graduated in the last few years, and the rapid advancement that they've seen, even within 3 or 4 years post-graduation, that might have taken students 7 years to get to those places before. They're going to carry this information with them. They're going to bring an interest in these materials with them. And so we thought, it feels like the payoff is going to be a lot better focusing on students. There's a lot of organizations that can handle professional development for industry members, for practitioners, but we should really put our focus on students, right? We're professors, we're teachers, we know students, we know them well, we're well positioned to do that. And so we made that decision, and I guess NSF agreed that we had a pretty good idea.
Perfect. And on that grant or that research, we understand that there was really a problem that you wanted to solve from the industry side, but what was or currently is the industry involvement on it?
Yeah, we've got great industry involvement. We created, I think we're calling it our technical advisory committee. So the work is guided by about 11 or 12 pretty significant national and international industry leaders in this space. We've got several companies that are located here in Michigan, either companies that were involved with the design and construction of our building, or companies that have taken on leadership roles since then as they've gotten more interested in this material. We've got one of the largest connector manufacturers in the world that's part of that group. We've got probably the most active mass timber general contracting firm in the US. They're based in the Pacific Northwest, of course, but they're part of the technical advisory committee. And they're the ones that help keep us focused, help keep us, back to reality in terms of what we're doing. And they're also the ones that frankly are going to be sharing project documents so that we can bring real project documents into our virtualized environments so that students are learning lessons based on what's taken place in the field, not, sort of what we think might be a good lesson for a student to learn. So it's pretty tightly integrated, and we're pretty excited about that as well.
Very good. So this is a project you've just started, right? So I'm not sure if you have any results right now, but I wonder, like you've mentioned about the virtualizing the building, if I may say so. Is this something that would be available for everyone to look for? So just kind of a plug for our listeners to kind of stay tuned. Where can they find this information?
Yeah, absolutely. So the goal of the project is actually to have maximum outreach during year 3 to students. So it's going to take us about 2 years to get all the curriculum built. And then we're going to pilot test it in year 3. And we want students from around the country to be involved with that. So what we're going to be doing is we're going to be uploading interim products as well as finished products to our masstimber.msu.edu website. There's nothing, I mean, there's other things there now, but nothing about this yet. But we'll be uploading things there. And then we're actually going to also be reaching out to faculty across the US who would like to incorporate this material into one or more of their courses. And we're going to be holding some faculty workshops, not the summer of 23, but the summer of 24. So we'll have some paid opportunities for faculty to come to a workshop. We'll introduce them to the material, get them comfortable with the material. And then the idea is that they would bring the material back to their school and try it out with their students in their courses. So hopefully we'll get somebody from Purdue that's interested.
Yes, that is very interesting. We're gonna try and put a little plug in the somewhere with that link, so students may stay tuned. I mean, our viewers can be anywhere from students, people that are interested, so that would be extremely helpful.
Great.
And then one final question that I have now geared towards more on the undergraduates. What do you see as benefits of getting involved in research project at the undergraduate level? And how do you think that knowledge could be used also, even if they don't, decide to go to academia, if they want to do an industry route?
Yeah, perfect. Great question. So what we hear all the time from our industry advisory board members, they want students who can communicate in writing, who can communicate verbally, who are critical thinkers, and who are analytical. Those are kind of like the big 4 things that we hear all the time. If you get involved in a research project, you will learn how to be a good writer because you will be writing. And the way you get better at writing is to continually write and get feedback on that writing. So your writing performance will increase. Your confidence in your writing will increase. The same with your verbal communication. Research sometimes is a lonely endeavor, but I think in 2022, most of us are doing more collaborations in our research. And so you're going to build skills in interpersonal communication. You're going to build skills in giving presentations because part of research is communicating what you've learned to others. So you're going to get some skill in developing PowerPoints and presenting those, which is kind of like going out on a pursuit team, bidding for work, right? Being interviewed for work in a construction firm. And then the critical thinking and analytical mindset, I think, goes without saying. If you're working in a research project, you need to be very organized, very detailed. And that's going to build as you look at your data, as you look at what's coming in, and you start to build your findings, build your inference from the data. Your critical thinking skills and your analytical skills are going to, again, go up. So those, I think, those are the tangibles. If you say, man, I don't ever want to go to grad school, I don't ever want to think about this stuff, doing a research project can help you greatly in that way. But on the flip side, never say never. You might say today, I never want to go to grad school and do this stuff. And then you get the experience with it and you say, wow, this is great. This is actually, I didn't even know this is what I wanted to do. And now I want to do this. And you find a whole new area of interest for yourself. So I think there's a lot of benefit for students to get involved with research, regardless of where they want their career to take them.
That's all the questions I have right now. Thank you very much, Dr. Berghorn, for your time. And this was all very interesting. We learned a lot about mass timber, so getting excited, specifically looking out for this new material that will probably come up more and more in the US.
Absolutely. Yeah, thanks so much. This was great fun.
Thank you.